Hello friends, so today I am going to talk about DFS traversal in a graph. DFS by means stand for depth first search and it is highly useful in a graph. Okay, so today I am going to talk about the algorithm and the code that we use to write. Okay, so I had seen a lot many videos in YouTube which depicts the same topic, but what I thought was missing was that they did not discuss the code. Most of the teachers or most of the YouTubers discuss the algorithm and then they give the link of the code in the description box, and they don't explain the code actually, and we are not able to sometimes we are not able to relate with those codes with the algorithm that they have stated, right? That's why I decided that I will start a YouTube channel, and this is probably my first video on the topic, and this is quite a simple topic. In the future also, when I make videos on difficult topics, I will relate both the algorithms and the codes. Okay, so this was what my aim is, and let's start with DFS traversal in a graph. This is a very simple topic, and I think while you have started this video, you must have a clear knowledge about what graph is, what are nodes, what are vertex, what are edges, right? And what is the difference between graph and trees, right? So there is a very basic difference between both of them, and uh, every tree is a graph, if basically I mean to say that. And the only difference that graph has as compared to tree is the graph can have cycles. Okay, the graph can have cycles like this one, but the tree cannot have cycles. It can only have branches, and the cycles are not allowed in tree. This is only the basic difference between graph and tree. And now let me start. So you see I have a class called graph, and here I have a constructor where I have this adjacent list. You see what I will basically do, what this adjacency list is used for. See, for every node the list will be storing. This is an array of linked list type integers, right? This list is an array which is of type linked list integer, right? So it will contain all these nodes, okay, and inside that array it will contain the connection to those nodes to which it has connection. That means in the adjacency of 1 I will have 4 2, okay, and this will be stored in the form of linked list type. That means we will have a node attached to here. That means this one has a link to fourth node and the second node. Okay, so this is how that is why we have defined linked list, so that the size is not specified. It may have 3 nodes, or it may have only 1 nodes, or maybe 2 nodes are there, right? So this is a very important thing, and this is very important to understand. So the array will contain all the nodes starting from 1 to the 10th, or how many nodes are there, okay? And the inside that array will have a linked list where we'll have a link of that node with every child of it, right? So this is the basic definition of adjacency list. This is very important, you need to understand this we are highly going to use throughout the graph. Okay, so adjacency list is important to understand. Okay, what we are doing here, we are calling the graph from the main function, calling the making a new object of the graph class, and we are making a new linked list. Okay, and will traverse throughout that linked list. And moving on to add edge is nothing but a function which is used for adding the edge on the list, okay, for any node. See, this is the node, maybe value of v is 1. And see what I'm doing, I'm linking the code with the algorithm, right? And finally I will tell you the basic traversal thing. So if you understand what these all are, then you can directly jump onto the code, which will be explained a few minutes later, right? So I'm trying to explain every part. Okay, so this is the node, and this is the child, right? This is the child which we have to add to this node. Okay, so maybe for example we can take 1 as the parent child, and w is the maybe the fourth or the second node, which is the child of v, right? So this is child, and this is nothing but parent, right? Okay, for example this is 1 and this is 4, right? We are calling that particular uh, element of that array. See, adjv. That means we are calling that particular element of that array, that is the one here, the parent array, and we are adding into that the linked list is called, and there we are adding the child. Okay, so all those childs of v will be added here. Okay, so once 1 and 4 will be called, once again 1 and 2 will be called, so in the same manner everything will be added, right? So this is the add edge function. If you have any doubt, you can ask in the comment section, I will clarify the doubt there, right? So this is the main function for which we are here, DFS traversal in the graph, right? So DFS is very important because you see what DFS will do, depth first search, what it specifies. You see, we are in a node. First of all, let me explain the algorithm. We are in the starting node. Okay, starting node can be anything that is specified by the user only. Okay, yeah, we are in a node. We check the nodes which are neighbor to it or which are its child. We go to one of the node, like if it has a child, we print this node and we go to that node. Okay, and we ignore this one. I will tell you, see. Okay, from here we will again check how many child it has. When it encounters a child, okay, what we'll do, we'll print that and we'll move to the next node. Okay, then again what we'll do, we'll see whether it has a child. Once the child is found, we will move to that node and print it. Okay, when the null is found, it will return back. Okay, similarly, so we had started from here. Okay, so again when one child was visited, it will not be visited again, it will look for another child if it has. If another child is found, that child will be printed and we will move to that node. Okay, and then again children will be found and subsequent operations will be done. This is how we do it. What we did here again, let me now explain it from the code. You see, we have we have an array of boolean type, visited array of boolean type. Okay, here we are going to specify whether in particular node is already visited or not. Okay, this is very important because in graphs we can have cycles and we can return back to a particular node which is already visited. Okay, so this is very important. I will show you one example of cycle as well. Okay, now we are calling this DFS util function because see, when the user will call a function, he will only specify the starting node. Okay, and we have to take this extra array. That's why we are making another array where we will have this visited as the argument array, right? Now what we are doing is, this is the starting node, this is visited now, so now we will put this visited of that node as true, right? And we'll print that particular node. Okay, now what we'll do, this is Java code, that's why I don't know how you will do it for C or C++, but if you are familiar with that language, you can do it better, right? What we are doing, actually we are iterating through the list. Okay, that means in the adj of 1, right, we have this node as 1. Of that node we have a list, right? And we have stored already all the children of that particular node. Okay, so we are going to iterate through it. In Java we iterate through the list like this using iterator, right? There are other ways as well, but I prefer this as the best way. Okay, so iterator integer I as adj v, because this is the list which we are going to, we have different lists, right? We have these many lists, whatever size we specify, right? So for particular list, we are going to specify this list iterator, and I is going to traverse through every element in that particular list. Okay, which list? The node which we are on. Okay, so if I dot has next, until and unless we have children, we are going to move there, right? So what we'll do, I dot has next, it will check, and first of all 4 was entered as a children of 1, as a child of 1, so we'll move to 4. Okay, so what we do here, you see, I dot next, int n equals to I dot next. Now we have moved to fourth node, right? Because I think you understood, right? If this fourth node was not visited, then we will recursively call this function again. Okay, with this node, the current node, that is the fourth node, and with the updated visited array, right? And this function will be called again. It will be put the node is visited, so it will be put as true, and we'll print that node. And again we will form the iterator for this fourth node. Okay, for the children of this fourth node, the list of this fourth node is called from this, and a list iterator is created, and will iterate through all the children of this node. Okay, now this is suspended. The task of one is still suspended, because as soon as we found there is a node, we moved to that node and we called the function recursively, while the working of the while loop was still left. Okay, it had another child as 2, one had this node, right? So we have basically not moved to this node. We found a node, we moved there, right? Again we found a node, we printed that node. Again iterator was created, we found a node, again we moved to that node, the same thing is done, and we moved here, right? Once this task is completed, once here we have moved. Okay, okay, I think we are missing one checking condition here. We will have to check it, that whether if the edge is, or the, if it is null. Okay, if the node, if there is no node next to it, right, then we'll have to return back, right? That is one thing to be added here. Okay, once we return back, the while function is still in function, right? Okay, so again it will check whether I has next node, right? This one, this is going to check. Okay, if I has next node, then it will move to that. If it is not visited, then we will visit this node. Okay, and we'll again check whether there are children of this node or not. If it is done, then we'll move back. It will check whether there is another node or another child for this particular third node. If it is not there, then we'll this while loop is completed, so we'll move back to the function which had called it, and which had called it, the fourth node had called this third node, right? And we'll follow the same procedure for this one as well, and the whole procedure will continue, and finally we'll have a DFS traversal, right? So what should be the DFS traversal for this particular graph? See, this is one. I think this is not so clear what is written, because I marked it too much. So I will tell you, I will point to the node in which we are standing. This is one will be printed. We move to 4 will be printed. I think the video is getting longer, I will try to shorten it. Then we are here in this node, we found 3 will be printed, then 10, then 9, then we move back, no children, then here we come, 2 is printed, then 5, 8, no, we move to 5, then we check is there any child, 6, then we move back, no children again, move back to 8, and then 7, 8 and 7. So this is the DFS traversal of the graph. I think you have better understood this. You can apply same for circular graphs as well, where cyclic graphs as well, where only the thing will be, if you see you have 1, 2 and 3 like this, you started from 1, you check there is a path from 1 to 2, you move here, you print 1 already, you move here, you see, you print 2, and you see that there is a path from 1 to 3, 2 to 3, you move to 3, you see that there is a path from 3 to 1, but you are checking here that you are moving there, but you are checking whether the particular node is visited or not. If it is not visited, then only that DFS traversal is done. If it is visited, as already 1 is visited, so we are not going to print it again, right? So this is the basic difference, and this is why visited array is used. I think you have better understood. This was quite simple, and if you like the video, hit a like button and subscribe my channel for more videos like this. I am going to make videos on more difficult topics from here, and I think probably if you have come later to watch this video, you must have got so many videos on this channel, and you can check the subscriber button if you have not checked it till now. Thank you for watching the video. Hope you enjoyed it. Meet again.